All right, so Roman numeral 6. What do you do if we don't have a unit circle value? So you're going to need your graphing calculators. Okay, grab your graphing calculators. And it will be very, very clear when you need to use a calculator. It will say use a calculator, or it will say round 2 decimals or 3 decimals. Otherwise, you should not be touching that calculator. So, letter A, if tangent x equals 12.8044, so that's pretty clear, it's not unit circle. So, in order to solve for x, we're going to need to take the inverse tangent of both sides of the equation. So when I do the inverse tangent of tangent x, that does produce x. And I want to go ahead and take a moment and go around the unit circle in radians as decimals, because this is going to help. So pi over 2 is 1.57. Pi, we know, is 3.14. 3 pi over 2, I calculated this earlier, was 4.71. And if you go the whole way around to 2 pi, that's about 6.28. So go ahead and jot those down, because this will really help you as we move into these. So when I look at tangent x equals 12.8044, if I look at the original problem and I say all students take calculus, there are 2 quadrants that tangent is positive. What would be those 2 quadrants? 1 and 3. All right, so on your calculators, when you do inverse tangent, 12.8044, what does the calculator spit out to? Okay, and let's go 3 places. So I got 1.493. Now I want you to stop, and I'm going to try and go nice and slowly today, okay? If I do 1.493, what quadrant is it giving it to me in?
The first.
In the first. All right. So that's one of my answers, first quadrant. How do I get the third quadrant value? How would I take this? So this is like 1.493. How would I figure out? Yeah, Eli? Yeah, you're going to add pi, or 3.14. So, just use your calculator, 1.493, adding the pi, we get 4.634. All right, so, now the reason why we added pi, let's make sure we're okay with this. The reason why we added pi is because from the first to the third quadrant, that is an angle of rotation of pi radians. So this is not true for all of the inverse trig functions. So here we go. In letter B, let's stop and think a moment first. If I have cosine x is a negative value, and all students take calculus, in what 2 quadrants do I want my answers from 0 to 2 pi? Second and third, okay? That's in the second and third. So we're going to use our calculators and do the inverse cosine of this negative decimal. And what are you guys getting to 3 decimals? Okay, that's what I got. X is 2.017. All right, now let's look at this little circle we did here And isn't that in the second quadrant? Okay, so now this is in the second quadrant. This is going to require some analyzing here. So that is one of my answers. But I want to get into the third quadrant, right? How might we figure out how to pop it into the third quadrant? Because it's not pi away. Amanda? Pi over 2. So you think from here to like in here would be 90? Well, okay, let's stop and think here a moment. Isn't the distance from the x-axis to that terminal side is theta prime? Penelope?
3.14 minus 2.17 times 2, and then add it to 2.17.
Okay, so you're going to take the pi minus 2.017 prime, right? So let's do that. Do pi minus 2.017. So this one is really going to be one of the most difficult ones for us to do, is that inverse cosine. So I got about 1.125. So now what I would do, because it sounded pretty complicated, couldn't we just take pi plus the reference angle? Yeah.
All I was saying was that if you multiply by 2 and then add it to 2.017, which is the same thing.
Oh, yeah, that is true. Okay, so she said you can figure that out and take your 2.017 plus 2 of those. Yeah, that certainly works. So either way is okay. I noticed that the distance from the x-axis to the terminal side is theta prime, whether I'm in the second quadrant or the third quadrant. So when I did this, I got about 3.142. Did I got that right? No. Is it 4? I think maybe I mistyped that. Hold on. So I said pi plus 1.125. Did you get 4.267? There we go. Sorry about that. Wait, that doesn't even make sense. And that makes sense, because I was stopping to think, I'm like, wait a minute, that's approximately pi. Didn't make any sense. So I have to be in the third quadrant, which is between 3.14 and 4.71. Okay, so when you're working with the calculator, this ends up being, I think, a little bit more difficult than when we do the unit circle. You've got to stop and think about what quadrant or quadrants is this value, your angle value, going to be. Then use the calculator, but then you need to know how to use that information. So suppose I had sine. If I wanted sine to be positive, sine x was some positive, I have to put it in the first and the second quadrant. If sine x were negative, I'd have to be able to put it in the third and the fourth quadrant with that reference angle. Okay? All right, so A and B, we're solving. These are fundamental solutions from 0 to 2 pi. So now I'm going to use the calculator again, but in C, I want to give general solutions. So let's take a look at this. It says solve secant squared x minus 2 tangent x equals 4. All right, there's a problem here. What's the problem? I have 2 different trig functions and it's not factorable with this. So we're going to use what we learned on Friday. Do you remember where we said sine squared theta plus cosine squared theta equals 1? That was one of our Pythagorean identities. But how do I get secant squared? So I do not memorize the other two, but I figure them out every time. So if I want secant squared, isn't that 1 over cosine squared? So what I'm going to do, to get 1 over cosine squared, I've got to divide by cosine squared theta. So that's what? Tangent squared theta plus 1 equals secant squared theta. So I'm going to use a Pythagorean identity substitution. So I'm going to replace secant squared x with tangent squared x plus 1. And then let's go ahead and subtract the 4. So what we've learned so far, let me kind of backtrack. This is our 3rd day on solving equations, and we're still learning new techniques. One technique was isolate the trig function. A second technique was factoring. See if you could factor. The third was using a Pythagorean identity substitution. Today, we're learning how to do these using the calculator and approximating, but I'm going to circle back through my techniques from last week within this. So here we go. Let's collect like terms. And I get tangent squared x minus 2 tangent x minus 3 equals 0. Okay, this one's going to factor. This will be tangent x minus 3 times tangent x plus 1. Check your work when you factor. Tangent x times tangent x is tangent squared x. The outer is 1 tangent x. The inner is minus 3 tangent x. So that's minus 2 tangent x. Negative 3 times 1 is negative 3. So this will give me tangent x equals 3. And this one gives me tangent x equals negative 1. Now, tangent x equals negative 1, this is unit circle. Okay, I should recognize that's unit circle. So I can do that one, and I can change them. Well, I want the general solution. So that'll be what? 3 pi over 4 and 7 pi over 4. I'll generalize that in a moment. Over here, this one's not unit circle. So we're going to take the inverse tangent of 3. Go ahead and use your calculator. And are you getting 1.249? So now let's write the general solutions. Tangent x is 3 in the first and the third quadrant. The nice thing about tangent is to get from the first to the third and from the third back to the first, that's pi. So that's no big deal. So this will be 1. And if we want to go ahead and round 2 decimals, this one didn't say, well, I guess it does say up above. So we could do 1.249 plus pi k, and then the other one would be 3 pi over 4 plus pi k, where k is an integer. And that covers all of them. Okay?
How would you write the general solution? Is it like more likely the column is negative?
Okay, so great question. What about if I go back to letter B and I were asked for the general solution? So if it's second quadrant and third quadrant, think about how we did it last week with unit circle. If it's second quadrant, you do plus 2 pi k, and in third quadrant was plus 2 pi k. That's an excellent question. Here in letter A, because it is tangent, I would take my 1.493 plus pi k, because that takes care of tangent every time. If it were sine, and sine were, say, positive, it would be the first one plus 2 pi k, second quadrant plus 2 pi k. All right. Well, let's one more level here in Roman numeral 7. What about if it doesn't factor and we have to do quadratic formula? I know. Like I'm almost afraid. I'm almost afraid right now. Okay. So watch this. Yes. Okay, so here we go. All right. Sorry guys. So here we go. Buckle those math belts on. All right, here we go. If we're gonna do, it doesn't factor, okay? You're gonna try to factor it. And I'm gonna do a U substitution because okay, maybe we don't know what to do. So, let's let U equal sine x. And I have U squared minus U minus 1 equals 0. Alright, again, you would want to try to factor it first, okay? You would want to try to factor it first. It does not factor. So, quadratics, what you learned back in Algebra 1 and in Algebra 2 was quadratic formula. The thing is, we're not using the letter x here with this U substitution. It's in fact the letter U. So just, I mean, it's a technicality, but it's the correct way to write it. So you would do negative b, so negative 1 is 1, plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a times c, all over 2 times a. So watch what we're going to do here, and actually it isn't as bad as it initially appears. I just knew it's Monday morning. A lot of you were absent last week, and you're like, I get it. So here we go. So this would be 1 plus or minus. Now be careful, minus and negative becomes a plus. So 1 plus 4 would be the square root of 5. I am trying to be very sensitive to go slowly here. Okay, so what we're doing again is we've got a quadratic trigonometric equation. It doesn't factor. So if it's quadratic, we can use quadratic formula with the U substitution. So go ahead and use your calculators for me. And I did the 1 plus square root 5 divided by 2, and I got 1.618, or I got negative 0.618. I got two answers here. So use your calculators, make sure you got your 1 plus square root 5, hit enter, divide by 2, 1 minus square root 5, hit enter, divide by 2. So now, let's back substitute. And U is actually equivalent to sine x. We just did a brief substitution to make it into a problem we knew how to handle. So I'm getting sine x equals 1.618, or sine x equals negative 0.618. Now, what's the problem with sine x equals 1.618? There's a problem with this one.
It would mean that the opposite is larger than the hypotenuse, which could be true.
What do you mean by hypotenuse?
Like off of the triangle case, you know what I mean?
Uh-uh.
So like in the circle, right? Because like because
Oh,
sine is off the head.
yeah, okay. Yeah, now I got you. Okay. Or let's think of it like this. If stepping away from the unit circle a moment and you think about the parent function for sine x, the sine curve oscillates between what two values? Negative 1 and positive 1. So I think you're thinking of it correctly here, is that this piece does not produce a solution. Do this on your calculator. If you do inverse sine of 1.618, it's going to say not defined or error or something. All right, so then for this piece, again, let's look back up to our A and our B part. Sine x equals negative 0.618. And here, you guys, pre-calculus is a lot more analysis than what you've really ever done before. A lot more analysis. So if I have the sine of x is a negative, what two quadrants should I be getting my angle in? 3 and 4. So think about that before you start pressing buttons on the calculator. All right, and we had to analyze that sine x cannot give a value smaller than -1 or bigger than +1. So this one doesn't produce a solution. So now go ahead and do inverse sine of negative 0.618. And I got negative 0.666. And so now we haven't seen one like this yet, so I'm glad we got to see it here. If I have a rotation clockwise of negative 0.666, is that not the reference angle? Isn't that the reference angle? It's just going clockwise. So what I really have then, so this was a clockwise rotation of 0.666 radians, so that means that is the reference angle. How are we going to find a coterminal angle that's in the fourth quadrant from 0 to 2 pi? Subtract it from 2 pi, okay? So you can take 2 pi, and it's not minus and negative, you just need to subtract it. That'll put me in the fourth quadrant between 0 and 2 pi instead of a clockwise rotation. So I got about 5.617. And then how am I going to get it into the third quadrant if I know the reference angle? Add it to pi, right? You're going to take pi plus that reference angle. So I got about 3.808. So when we work with the decimals, we're gonna really find out what you know and what you understand. If you were here last week and you're super confused, we need to find out like where are we getting lost? This is going back to early chapter 4, okay, very early chapter 4 of finding your reference angle and then converting it into your different quadrants. Okay, it's getting down to that foundation.
So you can just, to get it in the quadrant, you can add by any reference angle.
It's not any reference, it's the reference angle. There's one reference angle.
That gets you there.
What? There's only one, it was 0.666. Okay? All right, let's take a look at letter B. Let's do it again. It says solve 4 sine squared x equals 2 cosine x plus 1. And again, this one's on the interval from 0 to 2 pi, so that's a fundamental solution. All right, what's jumping out at you on this one? Like, that's the cool part is tomorrow, I'm going to just throw all the different types at you and not say, do this one by factoring and do this one by quadratic formula. So when you start to look at them, you have to start registering, okay, these are my different techniques. How do I approach this one? So something's jumping out at me. Yeah, Molly?
Different, because there's two different.
Yeah, there's two trig functions. I've got sine squared and I've got a cosine. And I can't factor. So, what was a technique? We did this Friday and I just did it a little bit ago. Pythagorean identity. So, we have sine squared theta plus cosine squared theta equals 1. And so what I can do is I could substitute for the sine squared. So what that means, and this is what we did on Friday, and hopefully for those 3 or 4 of you that were absent, like if you didn't watch the video, then you are probably feeling extremely frustrated. So you need to make sure that when you are absent, you're watching that video, you're jumping on top of the things to take care of yourself. Alright, so here we go. I'm going to replace sine squared with 1 minus cosine squared. And I'm just going to change theta to x. And then I have it in terms of all cosines. And I need to manipulate this and get everything on one side equal to 0. I'm going to first see if it'll factor. If it doesn't factor, then I'll go to quadratic formula. So here we go. This is 4 minus 4 cosine squared x equals 2 cosine x plus 1. Let's get everything on one side equal to 0, so I'm going to add the 4 cosine squared, and then I'll subtract the 4. So if you remember your factoring, like when you're doing trial and error, I'm looking for two numbers for the outer inner that I'm multiplying to negative 12 but adds to 2. And there's no pair that does that. So it shouldn't take me too long to figure out it's not going to factor. So I'm going to do a u substitution and say u is cosine x. So that's 4u squared plus 2u minus 3. So I'm going to pause, and I want you to do quadratic formula. Get your two values, back substitute that u is cosine x. See how far you can get on your own this time. I rounded 2 decimals this time. So I'm getting u is 0.65 or negative 1.15. Are you guys getting to that point? The nice thing is the cosine x equals negative 1.15. That's smaller than negative 1, so that was not going to produce a solution. When I go to do the inverse cosine of 0.65, I got 0.86. And then what do you have to do to get the second one? Yeah, okay, so think about this. All students take calculus. That's first quadrant and fourth quadrant. 0.86, and if you go back to that little circle we drew, 0.86 is first quadrant. That's my reference angle. So then to get the fourth quadrant, you're going to take 2 pi minus this and I got about 5.42. So those are my two values. Oops, sorry.